Oh, wow, stream key doesn't change, it seems. Nice. So we are on container most order. Okay. Okay, let's go. Container with most order. I've done this. Height 10 vertical lines drawn such that two operations to the two endpoints. Or, wait, okay. Mm, 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 small, right, left, right, right, and after we compute. So let's say 0, 1, 2, right? So that's 0, 1, that's this thing. 0, 1, 2, 3, 4, 5, 7, 8. 8 minus 1, 7. Okay, so just the difference. Indexed water is equal to min of, sorry, max of water, comma, h star. हॅलो. हां. हां, आलं ना. मी तुला थोड्या वेळात करतो जरा. मेसेज करतो तुला एक मिनिट. Yeah. So water is calculated if height of left is smaller than height of right. This will be a water level. It's plus. I'll say right minus minus. Let's say over here water. Being opportunistic, of course, the case compiles, everything is good. Okay, that's all fine. Let's move on to the next question, which is max number of k-sum pairs. Okay, so I have already devised a solution in my mind. So I don't remember how to sort the array. So I just take a look. Okay, I try sort. Start begin. Attend for sure. And now that it is sorted, I'll say left is equal to 0 and right is equal to 0. 0 and 5 sum is equal nums of plus nums of 8. Now if sum equal to k, that is to left plus plus and right minus minus. If sum is sum is smaller than k, then left plus is right minus minus, and we have to keep count, right? Count as 0 and just increase the count as 0. And I'll just return it over here. Pairs and I'll submit. This should be working. No, fine. Okay, verify out to 0. Should 2, right? So nums. Let's check the sorting ones. Of course, how to sort an array in, sorry, vector, right? In C++. We begin, we end, right? Yes, so we begin, we end. Ascending order, right? Yes, this is ascending order file. So sorting is done in log n, and while left is equal to right. Sum is equal to this, and sum is equal. It means you have found the pair. Else if sum is smaller, to increase. What is the issue? Okay. Memory seems alright. It is not going right here. From the array, so that means basically this. The sum is smaller, right? This should enter, right? Of course it should not. And now start size -1. I think this should work now. Yes. Okay, very successfully debugged. That feels right. And it is working pretty well. I don't think so we could optimize this further. Do solutions, and I'll just check once hash table counting. But hashing is pretty odd, right? Yeah, of course, complementary is present, and then first create a hash map, then k minus name, right? Of course, frequency just reduce it. That is fine. I mean, the hash map, but again, that is comes under the cost. I prefer this thing. Okay, we'll just do the hash map as well, because this was pointed out to be in 2 pointers. I was absolutely 2 pointers, so I'll do it in unordered. Just check unordered map syntax. Map syntax plus adding, finding a key, etc. So unordered map is this. Okay, mapping what to what, and not equal to end, right? Okay, everything seems fine. So I'll have an ordered map of number integer to its frequency, integer, say it is frequency. So for auto num in nums, if frequency dot find num not equal to frequency dot end, then frequency of num plus plus else frequency of 1, because we've not found now. Okay, I think we can do it over here as well. So if frequency and complementary is equal to k minus num, complementary, if we find the complementary, it is frequency one, or it will require the complete hash map. So I'll again go over here for auto num in nums, complementary is equal to k minus num frequency dot find complementary is now integral frequency dot end. If complementary exists, then I'll just do frequency and frequency of frequency of complementary, then 0, right? That should exist. Of complementary minus minus frequency of num minus minus. Just have a count. Same number as it. If num is equal to com, if num is equal to com, we'll do these two ands. Num minus minus frequency of com minus minus. Let's check now. This is for the same and this is for not. That is one half and multiple as well, I think. Okay, of course, 3. num to the 0. Num 0 as well. I have a better one. Now that it's map int, so let's say it as hash for auto xing nums int comp k minus num k minus x, I believe, if frequency dot comp, sorry, hash dot find comp not equal to hash dot end. If we find it actually, so I'll just have int count as is equal to 0 over here. Now just increase it, count pairs plus plus, and I'll just, let's say, hash of num, which will be available space plus plus, and I'll just write down count pairs. Here, of course, hash of count is greater than 0 as well is required, because once it is initialized it can even go to negative, right? What is different in this code? How come? Does it suck? No, it doesn't. Oh, of course, why will it? Hash of com minus minus. Okay, we are moving on to an easy question. Slide in window. I'm particularly not good, but I'll do it. We are given an array nums concept. This subarray length 0 to k. It has maximum average value and return this value to be less than calculation, but I don't know how I can do that. I'll just double whichever has the maximum subarray that will have length to k, right? So sum is 0 or entire is equal to 0 as 1 ki plus plus these are possible contiguous arrays, right? No, they often do. Not an issue. Sum is equal to nums of I. To make it a double. And what level it goes to go. You also have to have the double sum and have to add it into it. And so I have to right, so I have double max sum I'll initialize with it, and I'll say int right is equal to k and left is 0. Right is start size k minus 1. Okay. So sum plus equal to nums of k, sum minus equal to nums of left, right, and I'll say left plus plus, right plus plus, and I'll say max sum is equal to max of max sum and sum, the return max sum by k, and it should work, but I think this accepts only integer, not double. Oh no, it does, so that is fine. Okay, the window was sliding, this is good. Maximum number of vowels in a substring of given length. Iterable but not mutable, right? The size is la 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 I should do this in Python for some reason. Have I done this? Okay, wow, I'm not. So I will max also will count as equal to 0. Then I'll go and I'll say first substring, right? So left is equal to 0, right is equal to k. I do the initial vowel count for C in S of just first k elements. If C in A in list of person, list of A, E, I, U, then for count plus equal to 1. Now while right is smaller than k, smaller than f to POW vowel count if so left list of A, E, I, O, U. If it is a vowel, then vowel count minus minus is equal to 1. And if S of right in list of A, E, I, O, U, everything is going lower, right? This is lower. Wow. Count plus equal to 1. And I'll say final count is equal to max of final count and a potential vowel count. I'll say return. Till you hear the cry. La, 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 la. ये भी इसी का इसने one. Okay, this should be it's not size. Yes. The sun is a rise and a fall. Falling in the sky till you hear la 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 la. So it's GPT. Maximum consecutive ones. Okay. Okay. Oh, hint is there. Okay, returns the number of consecutive ones in the array if you case it. If one continue. I make it one K2, right? So I'll flip two zeros. Yeah, just make you the zero. Then I just should k minus minus s plus else k greater than zero. K greater than zero. And k minus minus is left plus plus. Che pane che ci interessare mangio futuro. La 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 la. Of course, max max and comma minus left plus one because these are indices and return max. Sign. Example consecutive ones. Hey guys, Greg here. What's up, guys?
And another integer k, and we want to return the maximum number of consecutive ones in the array if you can flip at most k zeros. So we're given a binary array. That means all of the entries are either 1 or 0, and we're given another integer here, k is equal to 2. So what that means here is we can flip at most k zeros. We can flip at most 2 zeros. Okay, so we're looking for consecutive ones.
Does this work?
And we want to know the maximum number of ones we can get if we can flip 2 zeros to be ones. So here we can obviously get 3, and here if we flip both of these 2 zeros to be ones, we can get 5, but actually we can get a better one, 6. For example, if we were to flip this one and this one, then we would have these 6 in a row would all be ones. That is going to be the best we can do, which is 6. And there's another way to get that. We could also get those 6 consecutive ones if we were to do this. And oh man, we're definitely not going to look at that example. That is way too complicated. So what we're going to do here is a sliding window. And for a sliding window, we are going to use 2 pointers. We set L and R both to the beginning at first. So that'll be the first index, which is 0. And so R is going to expand this window and L is going to contract the window. And we're saying window because window is going to be the same as any subarray. So we're looking Looking at subarrays or equivalently windows, and the window will be defined by the left side will be our L and the right side will be our R. And right now they're initialized at the very beginning. Now we want to keep track of a few things. We want to keep track of the max that we've seen so far. So I'll just call this max W for max window length or max width equivalently. That is going to be equal to 0 because we haven't seen anything so far. But this is going to be the thing we return. It's the maximum length of any window that was valid. And we'll talk about what valid means in a moment. And we also want to keep track of the number of zeros that we have. So num zeros, so far we have none of them. And we want to keep 3 zeros here. Well, that's going to be invalid because we can only flip. We want this to be less than or equal to k. Okay, so any more is actually valid here. 4, because it's a 1, not a 0. And this current we have not any more zeros than we did before because it's a 1, not a 0. And this current window we're looking at is actually valid here. It's valid as long as this value here is less than or equal to k. And it is less than or equal to k. It's less than or equal to 2. Okay, so this window is valid, meaning that we at least saw a max length of 1 here. You can always get the length of our window by r minus l plus 1. This is going to be 0 minus 0 plus 1 because these are indices to this beginning. Now let's try and find a bigger one. When we're looking for a bigger one, we'd move R over, which is going to try and expand our window. So is this valid? Well, yes, we're not going to have any more zeros because this was a 1, and so nothing really changed here. All we did is see a bigger window, which is now 2. Okay, let's look for a bigger one. We're going to expand our window over here, and so this is going to have 3 ones in a row. Well, nothing really changes again. This is simply just going to be 3. Okay, now when we move it over, it starts to get a little more interesting interesting here. So we saw a 0. Since we saw a 0, we now have 1 0. However, this is still okay because we are allowed to flip this. We're allowed to flip 2 zeros to be 1s. And so 1 is still less than or equal to 2. So we're allowed to do this. And so this is currently valid. Therefore, the current window length is 4. There's 4 things here. And so we can do 4 there. Okay, now when we move over here, it's getting really close here. We actually now have 2 zeros. And so this still holds for now. And yes, we can have a window length of 5 because we have 5 things here. But we've flipped as many as we can here. So as soon as we run into a 0, which is right now, this is no longer valid. Okay, this is not a valid window. Therefore, we actually need to fix this because we have 3 zeros. We need to make this hold again because this doesn't hold right now. So to make it hold, we need to contract the window by moving over L. Now, if this is a 0, then we'd want to decrement our number of zeros because we'd be losing a 0. But that wasn't a 0, so we have nothing to do there. When we get here, just before we move this over, we're going to say, okay, we actually have 1 less 0 than we did before because we're moving this in here. So now we have 2 zeros again, as it says here. Our window.
Got the point about the decrement. Nums of right. Equal to 0, k is equal to 0, then this is then nums of right is equal to 0. If k is greater than 0, I just say k minus because k is smaller than equal to 0. K might be 0, right? We'll have left is plus if nums of left 0, then we give up rights and just k plus over here. Just do this over here, right? It's really low. You can ask a friend, this is for telling me I'm really cool, it's a little bit. Just use up a 0. while k is smaller than 0, if nums of left equal to 0, then I just show k is plus left plus plus. Just use up a 0 if you are using an extra 0 until we free up a 0 we won't leave. Have I done this? No, right? Fresh problem. Okay, let's go. Yeah, you should delete one element from it. A is equal to 1 int k and flip just 1 0. So let's say int left is equal to 0 int right is equal to 0 while right is smaller than nums dot size. What I'll do is if nums of right equal to 0, I'll just do a k minus minus. What I'll do is if while k is smaller than 0, if nums of left equal to 0, then I'll just increase as the left will increase and right will increase. And max length is equal to int mean, and over here max right is left minus 1 and down max this is easy. Use up and if it's in, hold on. How many have we done? That's the big question. What does the subsequence say? Okay, GCD, right? Yes, zeros. Of course, that is easy. Then maximum is sum. Do these two and call it a day. 17 out of how much we have? Hash math. Stack if q linked list. We have binary to the important of another node. Binary search graph will binary search will do after DP node. This should be done pretty well. Okay, this is pretty easy. Just prefix sum concept, right? Prefix sum is equal to 0. And what we'll do for auto left in prefix sum is equal to left and max or to the which mean let's make it 0. Max art sum max. Find pivot index. Okay, I don't know how this will go. We'll do now scale with the pivot index. Range plus 5 or 0 is for some return I else prefix is equal to nums of I sum minus 0 I three plus 1 plus account. Sum of all the numbers strictly to the left of the index. Strictly. Okay. So sum 0th element Radhika ఇస్తున్నా. Yeah. It's 6, 7, 8 right now. That is enough, I guess. Put me in the flash map, stack, queue, linked list, and binary tree remain. And binary search, right? I'm not doing this. I might do intervals. Let's see, okay. I think this is a good stop for now. Just end this streaming now. 2 hours, 1 hour.